Okay, so today we're going to be talking about short field takeoffs and maximum performance climbs. All right. So the objective of this lesson aims to ensure that the student possesses the appropriate knowledge, skills, and judgment to perform a short field takeoff and maximum performance climb safely and consistently. The lesson should also ensure the student is able to calculate performance from charts in the POH of the aircraft being used to make the proper risk management decision before flight. The airplane flying handbook says that a short field takeoff involves the pilot operating the aircraft at the maximum limit of its takeoff performance capabilities. This contains two key aspects: simultaneously minimizing the ground roll and maximizing the angle of climb to allow obstacle clearance on short runways at high density altitudes and or at high gross weights. Careful execution of this procedure is essential for achieving stated performance numbers and extracting maximum performance out of your aircraft while staying within the margin of safety. A short field takeoff requires many of the elements of a normal takeoff, including basic aircraft control principles, trim control, directional control, wind correction, situational awareness, and proper communication. In environments where a short field takeoff is required, such as airports with short and narrow runways, these elements may be even more important, so you should not neglect the things that you've already learned about performing a safe takeoff. Prior to your flight, you should review the performance charts in the appropriate chapter of the POH. So for the Piper Archer, it is chapter 5. And you use these to calculate how much distance you will need to lift off and clear the obstacle. You also might be a good idea to consult the obstacle departure procedures and the terminal procedures publication for information on takeoff obstacles for each airport of intended departure, so that you can get the exact height of the obstacle that you are trying to avoid. It's important to consider both the actual runway length available for takeoff, as well as the distance required to clear obstacles at or near the departure end of the runway. We will perform all of these calculations using the Flaps 25 takeoffs performance chart for clearing a 50-foot obstacle. We normally use this chart for all of our takeoff procedures just because it'll give us the most wiggle room because it's the most restrictive. But it's especially important to use this chart for short field takeoffs because we're actually going to have flaps at 25 and we might actually be clearing a 50-foot obstacle. The ground roll chart determines how much runway distance we will need, but does not provide obstacle clearance. So, in the figure, there's a sample calculation provided. So we've got an altitude of 2,000, temperature 23, and a weight of 2,400 with an 8-knot headwind. So we'll go to this chart and we'll look at it. So how you're going to do this is first, you're going to go to your temperature. So we've got 23 degrees Celsius. And we've got a 2,000-foot runway. So you would take a pencil probably and go up to this 2,000-foot mark and then go directly across to this next section. And now we're going to look at our weight, which we have 2,400 pounds of weight. So you're going to follow these lines down until you hit that 24 point in the chart. And it says 24 and not 2,400 because down below it says weight in pounds times 100. So once you hit this point, you're going to go straight across again. And now we have 8 knots of headwind. So you're going to follow the lines down until you get to that 8 point. And then you're going to do the same thing and go straight across. And so this says we have about 1,650 feet. So 1,650 feet of runway is needed to clear a 50-foot obstacle on takeoff roll with 25 degrees of flaps. This chart is also good for telling us our liftoff speeds. So if we are at 2400, we're going to be in between this one and this one. So we're going to be at 54 is our liftoff speed. And then our barrier speed is going to be 57. Normally, when we're taking off in the Archers, we're going to be in this lower category. So our liftoff speed is going to be 50 and our barrier speed is going to be 54. And then for this example, it's important to note that the associated conditions are a paved, level, dry runway with a new engine and also a very skilled pilot is performing to get these numbers. Right, the stated numbers should be achievable under these conditions with a new engine and propeller producing their full power and thrust. But conditions like that are hard to come by in the real world. A grass, gravel, or poorly paved runway, or one with water or snow on it, can affect your takeoff distance. Engines lose power over time and propellers lose efficiency, so those will also have a negative effect on your performance. And it's also important to keep in mind that if you are a private student, you won't do this procedure perfectly, so you'll also need more of a takeoff roll. So you should treat these calculated numbers as an absolute minimum, even in ideal conditions. And a safety margin of 1.25 to 2 times should be used in most circumstances. I would use at least 2 times when I would be calculating this, because if you think about it, 1,600 feet is really not a lot. Purdue's runway is 6,000 feet. And sometimes even that seems a little short. So I would you want at least 2,500 feet of runway. So keep that in mind. If the calculated takeoff distance is close to the available distance, you should always err on the side of caution and consider using a different runway or airport, getting rid of excess weight, or not proceeding with the flight. So if you do have a runway that's at 1,700 feet, 1,800 feet, it could be a good idea to just not continue with the flight. You can drive, you can, take a different plane. You don't want to be cutting it that close. A short field takeoff requires the pilot to climb at Vx, or the best angle of climb speed, as when clearing an obstacle is the primary concern. The angle of climb is the altitude gained for given amount of time, or given distance traveled over the ground. This is more important than Vy, which is the rate of climb, which is the altitude gained for a given amount of time. In the Archer, Vx, or the rate of climb, is 64 knots with flaps up. Liftoff speeds are given in the takeoff performance diagram, where we showed that, varying from 50 to 55 knots depending on the takeoff weight. Flaps should be retracted at a safe altitude, and once the obstacle is cleared, you should pitch for Vy. So the only reason we're traveling at Vx is to clear that obstacle, because normally we would want to travel at Vy so that we can gain the most amount of altitude per time, because distance doesn't really matter. The only time that the altitude per distance matters is when we're trying to clear that obstacle. So for example, if this is the obstacle and this is my plane, you gotta get that best angle of climb to get up as quickly as possible distance-wise. But once you've cleared that distance, you can pitch for 76 so that you can get the most altitude per time. And then once and you can start lifting up the flaps, and then you will pretty much do a normal climb, and then you can do the climb checklist at 1,000 feet AGL. For a short field takeoff, you want to use the maximum available takeoff distance. This may mean taxiing to the end of the runway before setting up for takeoff. The taxiway may not take you all the way to the end of the runway, as is the case for 2-3 in Lafayette. You might need to taxi back down the runway or perform a 180 to maximize the runway available. When making your hold short call to tower, you should request a short delay on any maximum performance takeoff. So when you're making that initial call to tower, say, for example, if you're in Purdue 57, holding short, runway 23, ready for departure to the north, requesting a short delay. Then tower will know that you're going to be doing a short field takeoff because you're going to take a couple extra seconds on the runway than you normally would, and we'll talk about that when we talk about the procedure for doing a short field takeoff. You should especially notify tower when back taxi is desired. We wouldn't normally have to do that at Lafayette because all of our taxiways go to the end of the runway. The runway may also have a displaced threshold, which you can use for extra distance on takeoff. Here I will show you what the displaced threshold looks like. All right, so this right here is a displaced threshold. You can see it, it's marked with these arrows here, the white arrows. This is a blast pattern. So the yellow, looks like I'm glitching a little bit. So the yellow arrows are referred to as an overrun in case of opposite landing traffic does not have room to stop. This is not going to be used for normal operations. So you should not have to worry about this unless you're in an emergency situation. The displaced threshold, pretty much what it means is that you can take off on this section of the runway, but no, you cannot land. So you can take off here, but when you're landing, you have to land beyond here. So when you're landing, you should assume that the runway starts right here. You can only land here. But a displaced threshold is perfect for short field takeoffs. So you want to utilize all of that. And then this picture just shows the difference of where you would start for a normal takeoff versus for a short field takeoff. You can taxi back here. All right, yeah, that was example 3. It shows you how you would taxi back down a runway to use this full length. Take care to ensure the aircraft's turning radius allows it to make this 180-degree turn at the end of the runway, and look for obstacles like runway lights and signs by the sides of the runway that could strike the wings or tail. In some very extreme cases, it might be necessary to shut down the aircraft's engine and push it back to get maximum distance. But keep in mind that if this is required to get that extra couple of feet of runway, it might be a good idea to reevaluate your performance calculations and risk management. So decide if that couple feet really matters that much. Is it a good idea for me to be taking off at all? Probably not, especially if you are a private pilot. A normal takeoff often includes a rolling start from the hold short line, which takes up valuable runway length. So for a short field takeoff, it is important to hold the plane at a standstill while you bring the engine up to takeoff power, allowing maximum acceleration while using the entire runway. So how we're going to do this is we're going to hold the brakes, set the takeoff power, so full power. You want to check the engines, make sure they're in the green, and then you'll release the brakes. Standing on the brakes for too long can at full power, will wear them out, so only a brief hold is necessary. So the procedure for a short field takeoff: to perform a short field takeoff, proceed with your normal taxi, run up, and before takeoff checklist. Set the appropriate trim and flap settings and take note of the wind conditions. So for a short field takeoff, you'll do 2 notches of flaps, 25 degrees of flaps. Perform a departure briefing and contact tower asking for a short delay and or a back taxi if required. Line yourself on the center line and come to a complete stop on the runway. So that's when you're holding full brake, and then smoothly apply takeoff power, which is full power. Check your engine gauges, make sure they're all in the green, and then release the brakes once the engine is in takeoff power, which can be checked with the engine RPM. So it should be around 2,500. Apply crosswind corrections as you would for any normal takeoff and maintain center line with rudder inputs. At rotation speed, smoothly pull back and pitch for VX. So in the Piper Archers, it's 64. Once the obstacle is cleared, so 50 feet above the field elevation, you can announce obstacle cleared. You can start removing the flaps and then pitch for VY, which in our case is 76. Figure 4 provided from the AFH shows a basic demonstration of this. Oh. Figure 4, here we go. Yep. Rotate Vx, climb at Vx, you clear the obstacle, now you can climb at Vy. You can retract the gear and flaps. While this maneuver includes target airspeeds, it should be performed as a VFR maneuver and the VFR pilot primarily using outside references. It is important to not become fixated on your instruments, especially the airspeed indicator, but instead cross-reference your instruments with the outside picture. Like every procedure, you should be able to adjust and adapt for weather conditions, especially wind. A slight headwind or tailwind can make a huge difference in takeoff distance and climb angle relative to the ground, and crosswind corrections should be included. Okay. Okay, so the airman certification standards are what you will be tested on and expected to perform during certification. If you possess the proper knowledge and demonstrate good risk management and follow the proper procedure throughout the maneuver, you will be fine. You must remain within 10 knots above and 5 knots below the designated airspeeds. Less leeway is given with lower airspeeds because takeoff and climb phase of flight are particularly prone to stalls, which are often a result of improper airspeed management. So yes, those are your ACS standards, 5 knots below, 10 knots above. All right, in summary, we reviewed what short field takeoff is and how to decide whether a situation calls for one. Reviewed the elements of planning such as takeoff and aeronautical principles behind those elements. We've discussed the ways to set up and perform a short field takeoff, and reviewed the airman certification standards. Okay, yep. And up here, we've just got the procedure. If you need to write this down, that's okay. Just the flaps to 25, make sure trim slightly aft of neutral. We didn't talk about that. That could be a good idea since you're going to be pulling back so much. Get set up on the runway as far back as possible. Apply the brakes and hold. Throttle to full power. Brakes released. Rotation speed at 55. Except in our case, it's actually going to be around 50. Rotate to climb altitude. Once the obstacle is cleared, you can pitch down to 60, and then once the flaps are at 0, you can pitch for 64, which is and right, pitch for 60 and then pitch for 64. And then once you're retracted the flaps and after the obstacles are cleared and you're at safe altitude, you can pitch for 76. Okay.